Well, hi everyone. I got this practice test for you, and we'll start with number 1. Show that the points 2, -1, 5, 5, and 6, -3 are vertices of a right triangle. Alright, we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. So these will be the two smallest sides when we use the distance formula. So that's the other thing we're going to use. The distance is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So we got to do that 3 times. I'm going to call this A, this B, and this C. AB is the square root of, I'm going to go 5 minus 2 squared plus 5 minus -1 squared. And that's 3 squared. 5 plus 1 that's 6 squared. And we are talking the square root of 9 plus 36 is 45. Now I could simplify that, but when I plug these in here, the square roots will go away, and this will just be easy to just leave it like that. So let me do BC now. I don't know, I haven't looked at it very closely, but I don't know which one's going to be the longest side, but I'm designating that one as the hypotenuse when I'm done. So I don't know if it's going to be AB, BC, or AC. I'll wait until the calculations are done. So BC, I'm going to go 6 minus 5, square that. I'm going to go -3 minus 5 and square that. And I'm looking at 1 squared. -3 minus 5 is -8 squared. And that's 1 plus 64 is 65. And then AC. Okay. I'm going to take 6 minus 2, square that, plus -3 minus 1, square that. Okay, we're looking at 4 squared, and then we're looking at -4 squared. Six minus 2 is 4. -3 minus, -3 minus -1. That's -3 plus 1, so that's -2 squared. And then that's 16, and that's 4, that makes 20. Boy, if I'd have stayed with that, I would have concluded that it's not an isosceles. No, well, it is not isosceles either. I'll talk that in a second. It's not a right triangle, but now I think we're good. So let's see, I'll let this be my A, this be my B, and this be my C. So the square root of 45 squared plus the square root of 20 squared does equal the square root of 65 squared. Because square roots and square cancel out. That's 45 plus 20 equals 65. Alright, so Pythagorean theorem holds. Didn't give you or me enough room. Let me just... Therefore, these points make a right triangle. Okay, and then up here I'll just write, it's not isosceles. because there are no congruent sides. All right. Midpoint, number 2, midpoint between these 2 points. We're talking, we average the x-coordinates, or x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. Well, let's see, that is negative 5 plus 9. Those are my 2 x-coordinates divided by 2. And that is negative 3 plus 3 divided by 2. The biggest mistake I would see here is people not adding first. Just maybe they have their calculator go negative 5 plus 9 divided by 2. It'll divide this, just the 9 by 2 if you do that. It'll follow order of operations if you don't take care of that. So that's 4 divided by 2, and that's 0 divided by 2. So let's write that a little nicer. 2, 0. Okay. Number 3. Test for symmetry on the x-axis, the y-axis, and the origin. So let's do let's test for x-axis symmetry first. We are going to put negative y in for y. And a negative times negative is positive. So x equals y squared minus 5. And that is the same as the original equation. So it does have x-axis symmetry. When you get this, I do want you to test all 3. Y-axis symmetry. I'm going to put negative x in and have y squared minus 5. Now this is negative x equals y squared minus 5. That does not check out. It is not doesn't simplify to be the same equation. And then origin symmetry. I'm putting negative x in and negative y in, squared minus 5. Negative x equals y squared. That's what I had for y-axis symmetry. That's not working. Alright, so we do know it has x-axis symmetry. Okay, now just plugging that into the calculator is not going to work very well for us. I'm going to make a table and just kind of play around with it here a little bit. Let me put some values in for y, since x is by itself over here. Usually I do it the other way, but now negative 2 squared is 4. 4 minus 5 is negative 1. Negative 1 squared is 1. 1 minus 5 is negative 4. And I think I'm starting to feel like I have a sense of the symmetry of it now. But 0 squared minus 5 is negative 5. Right here is where I start to get that sense. 1 squared is 1, minus 5 is negative 4. 2 squared, that's 4. Minus 5 is negative 1. So I'm going to plot negative 1, negative 2. I'm going to plot negative 4, negative 1. I'm going to plot negative 5, 0. I'm going to plot negative 4, negative 1. And negative 1, 2. Okay, let's try to be fairly neat with our graphs when we draw those. Alright, first page done. Now we have the same directions as we had before. So let's check for x-axis symmetry for y equals negative x to the fourth plus 6x squared. So let's put negative y equals negative x to the fourth plus 6x squared. That's not working. It's negative y there. And we can't make that look like that. Y-axis symmetry. I'm going to put y equals negative x to the fourth plus 6 negative x squared. This negative's here. This part right here, even power, negative, that's going to be, so this is this negative here. This is x to the fourth. And then negative x to the second power is x squared, so plus 6x squared. I think we've got y-axis symmetry. And then origin symmetry. So again, check all three when you do this. So I'm going to put a negative y here, negative x here, and 6, and then negative x here. So that's negative y. I've already done this, and we had negative x to the fourth plus 6x squared. Origin symmetry looks like x-axis symmetry, so it is not working. Alright, let's make a graph of that. Yeah, while we're at it, we'll just make a... I'm going to go negative 2. This time, because it's y's by itself, I'll put numbers in the x column. I did the opposite on the previous, if you need to check that again. Okay. So, this requires a little bit of thought here. Negative, and then negative 2 to the fourth plus 6 times negative 2 squared. That is 16. So I'm looking at negative 16, and that is 4. 6 and 4, or 6 times 4, I mean, is 24. So I think we're at 8 there. Now, negative 1, this is one we could put in the graphing calculator, but I'm not doing it. Negative 1 to the fourth plus 6 times negative 1 squared. That's 1, negative 1 plus 6, looks like 5 to me. 0 is 0. 1, because of that, I'm pretty sure is 5 here and 8 here. That's where we see the symmetry. So it hits the origin. But let me not get ahead of myself. Negative 2, 8. All right. Wondering if I messed that up a little bit. Okay. Now let me... Negative 2, 8. I'm going to go back and recheck this. Something's not feeling right about it right now. Negative 1, 5, 0, 0, 1. That's this is negative 1 plus 6. That is 5. Okay. I don't know why I'm feeling funny about this. Okay, 2, 8. Now, I just wonder if it does some funny things in between. So, I just want to check it real quick. I'm wondering if there are things, there's bends in this that I didn't anticipate. So I'm putting negative x to the fourth plus 6x squared. No, I got a silly little... Let me look at that. Let's go zoom 6. We were doing other things in another class. Oh, okay. There is stuff going on here. So it's not going up. It comes back down from there. Well, I wouldn't have seen that without graphing it. Right off a hand here. So like negative, and then if I go negative 3 to the fourth plus 6 times negative 3 squared, this is negative 81. This is negative. This is 81, so it's negative 81 plus 54. Now that's negative 27, so I'm way at negative 3. It's way down here, so it doesn't go up like that. It comes here, gets up there, comes down, and then it comes back down again. So it makes this big old wham here. This is not here. Okay. Alright, solving rational equations is next. I see x minus 3, x minus 3. It's the only denominator. This is 1, so I'm going to use x minus 3. That is a minus. As my least common denominator. So I'm going to multiply the whole equation by x minus 3. Take x times x minus 3 plus 6 over x minus 3 times x minus 3 equals 2x over x minus 3 times x minus 3. Okay, so what do we got? We got x squared minus 3x plus 6. Those cancel, equals 2x. I'm going to add 2x to both sides. I got x squared minus x plus 6 equals 0. And I'm going to use factoring to do this, because I know, wait, 2 times 3, okay, I did this wrong, that's minus 2x, and I was also thinking the positive threw me off for a second there too, so I gotta be careful. Okay, now I'm still going to use it, but minus 2 and minus 3 will work there. So x minus 2 equals 0, x equals 2, x minus 3 equals 0, x equals 3. Alright, when I go back, 2's fine. 3 is not fine, because 3 makes this denominator. So I'd have 3 plus 6 over 0, which is undefined, equals 6 over 0. That's just undefined. So this is extraneous. And have I not been showing this? Sorry. Okay, the only solution is x equals 2. It has one solution. Okay, let's do this one here, number 6. X squared plus 2x minus 3 is x plus 3 times x minus 1 if you factor. Multiplies to negative 3, adds to 2, that does satisfy that. So that is our LCD. So I'm going to multiply through by x plus 3 times x minus 1. I got 4x plus 1 over x plus 3, and I'm multiplying it by x plus 3 times x minus 1. And then I have 5x minus 3 over x minus 1. I don't know. I'm just having them there is not hurting anything. I just started writing parentheses down. Okay, equals 8x squared over x squared. No, I'm going to write it as x plus 3 times x minus 1. I'm rewriting this in a factored form. And that's what we're multiplying through by too, so that helps. Alright, so we have 4x plus 1 times x minus 1 plus 5x minus 3 times x plus 3 equals 8x squared. 4x squared. Oh, let's FOIL. 4x squared minus 4x plus x minus 1 plus, it's not a minus, so I can just write it straight out. If it was minus, I'd be putting that in parentheses and then changing the sign. 5x times 3 is 15x, negative 3x and yeah, inside, and then negative 9 here equals 8x squared. Alrighty, I want to subtract 8x squared from both sides and combine all my like terms. 4 minus 8 is negative 4, plus 5 is 1. So that's 5x squared. Negative 4x plus x is negative 3x, plus 15x is 18x. Nope, negative 3 is 12x. 12x minus 3x is 9x. Okay, that's x squared. Negative 1, I did put that in there, right? That's 12. Yeah, okay. Negative 1 minus 9 is negative 10. So, I've got to go plus 10 minus 1. And x plus 10 equals 0, or x minus 1 equals 0. So x equals negative 10, or x equals 1. Negative 10 is in our domain, so that's good. 1, oh, this is another one. 1 makes that denominator 0. It makes this denominator 0. Pretty sure. Yeah, 1 plus 2 is 3, minus 3 is 0. This is another extraneous. So we got a couple to look at in that situation. All right. Next. Alright, for 7 and 8, write a mathematical model for the problem and solve. So a family has loan payments equal to 28% of their annual income. During the year, the loan payments total $30,510.23. What is this family's annual income? Loan payments equal 28%. So 28% of annual income equals $30,510.23. I'm going to put 0.28 for 28%. Of is times annual income, I'm just going to put x there, equals 30,510. I'm going to take units out for a minute here. And then I'm solving for x, the annual income, which requires me to divide by 0.28. Okay. 30,510.23 divided by 0.28 equals 108,965.11 is what I would write there for that. use units. Now, number 8. A car radiator contains 10 liters of 30% antifreeze solution. So you got a solution, 30% of the solution is antifreeze. How many liters should you replace with pure antifreeze? 100%. This is 100% antifreeze. To get a 50% solution. Okay? So, car radiator contains 10 liters. So this is the total. Alright? Our total, we want 50% of 10. That's what we want to end up with. Okay? And that's the amount of antifreeze in the radiator. Well, I would go 30% of, this is, how many liters should you replace with pure antifreeze? So we have 30% and we have 100% antifreeze solutions. We want the pure antifreeze, so that's the 100%. I'm going to make that my X, 100% of X, and then go 30% of the rest, 10 minus X. Okay? Part of it's 30%, part of it's pure. When we mix it all together, we want it to be 50%. Okay. Okay. Let's write the equation then. We'll take 0.3 times 10 minus x plus, this is just 1x, equals, and then 0.5, 50% times 10, and 0.3 times 10 is 3, minus 0.3x plus x equals 5. Alright, combine like terms. Negative 0.3x plus 1x is 0.7x equals 5. Minus 3 from both sides. We got 2. Nope. Okay. We got 0.7x equals 2. I'll divide by 0.7. And it's not going to come out exact. 2 divided by 0.7, 2.85, I'll go 2.86. That's a good rounding place. 2.86 liters. Okay, how many liters should you replace with pure antifreeze? So replace with okay, we're going to have to redo this one. I read it wrong. Okay. We have 10 liters of 30%. We don't have 10 liters of 50%. Okay, so, and we want to get a 50% solution. So I'm going to have to redo that, and I'll do it on the back of this paper here. I am really sorry. Okay. Okay, so let's put 30% of 10 liters plus 100% solution of X equals the total 50%. 10 was not the total. 10 was just how much we had of this part, and then we have this part, and 10 plus X is the total. Okay, that changes things, doesn't it? So 0.3 times 10 liters plus 1, or X, equals 0.5 times 10 plus X. 0.3 times 10 is 3 plus X equals 5 plus 0.5X. I'm going to subtract 0.5X from both sides. And 1 minus, so I have 3 plus 0.5X equals 5. Subtract 3 from both sides. I got 0.5X equals 2. Okay, let's look at where we are. So we're in the middle of solving this. And I think if you take 2 divided by 0.5, that's 2 divided by a half. I think you're going to get 4. And that's the question, if I recall, was asking how much of pure antifreeze, and 4 liters of pure antifreeze is what we solved for there. Okay, what else we got here? Let's look at number 9 here. The formula below represents the return of investment in a business application. The investment gain minus return on investment equals the investment gain minus the cost of the investment divided by the cost of the investment times 100. So let's let R equal the return on investment. We'll let G represent the investment gain minus C, which is the cost of the investment. This is G. Should have done this. C. This is C again. Okay. So we're doing this, and this, and then this, and then this, divided by C. Close those, times 100. All right. And we're going to rewrite the formula. Okay, so I did that. Then solve the formula for C. Now we got C in 2 places here. Let's see what we do here. I'm going to divide by 100. I'll get rid of this first. Anything that's over here, where the C's are, I'm going to try to get rid of. I'll write this as G minus C over C. Now, I know we're solving for C, but there's 2 approaches, and I know some of you like to do this, and I don't think that's a bad idea, personally, but I'm going to, first of all, just do this. I'm going to multiply both sides by C, and I've got CR over 100 equals G minus C. I'm going to get the C's on one side here. The reason I'm adding C, you know, we are supposed to be solving for C, but when I've got it on both sides, it makes it kind of hard. So I'm going to go CR over 100 plus C equals G. Okay, now we got the c's on one side. And I am going to actually factor out a c from both these terms. I'm going to put c right here. Now, this is c times r over 100, so this is r over 100, and then plus 1, and that equals g. And now I'll divide by r over 100 plus 1 here, and I'll divide by r over 100 plus 1 here, so on both sides. Now I've got c by itself. R over 100. I'm going to write 1 as 100 over 100. I got this complex fraction that I'm going to try to make not complex anymore. So I've got g over r plus 100 over 100. And then I'll write g, and then I'm dividing by this, right? So I'm going to write times 100 over r plus 100. See how thinking of the complex fraction as division, I'm going to rewrite it as multiplication and go by the reciprocal. And I'm just going to write one more step here, and I'll write it over here. C equals, instead of g times 100, I'll write 100g over r plus 100. Have this as my simplified equation that is solved for c. I did get c completely by itself. I didn't have it in two different places after we factored here. Okay. Number 10, let's solve this equation by factoring, and if I'm doing that I need everything on one side. So 2x squared minus 3x minus 5 equals 0. Okay, we are multiplying to get negative 10, right? 2 times negative 5, and adding to get negative 3. So let's use negative 5 and 2 there. I'm going to do the factoring over here, and then I'll write the factored form right here. 2x squared minus 5x plus 2x minus 5. Okay, GCF there is x, and I'm getting 2x minus 5 plus, and I'll use 1 for the GCF there for those. Alright, so 2x minus 5 times x plus 1 equals 0. 2x minus 5 equals 0, or x plus 1 equals 0. 2x equals 5, x is 5 halves, or x is negative 1. Okay. Now we are completing the square. Alright, I'm going to write x squared minus 4x equals, I'm adding 1 to both sides, equals 1. And now I want to complete the square. So, if you recall, I'm going to take b over 2 and square. b is negative 4. That is negative 2 squared, and that is 4. So I'm adding 4 here and adding 4 here. And I have x minus 2 squared equals 5. And then I will take the square root of both sides. This is a positive square root and a negative square root. And I got x minus 2 equals plus or minus the square root of 5. And I'll add 2 to both sides. And I'll write the 2 first, plus or minus the square root of 5. 2 plus the square root of 5 is one answer, 2 minus the square root of 5 is the other answer. And number 12. I'm going to add 1 to both sides. I've got 2x squared minus 7x equals 1. And now I'm going to factor. I get x squared minus 7 halves x. Okay, I'm not taking the x out, just the 2, because I want to use completing the square technique, plus something or other is equal to 1 plus 2 times whatever that is. This is a technique I showed you before. I did see some different ones where a lot of you were dividing by 2 and then doing it, and I thought that was a good idea. In fact, I might even show that way just as an alternative, just so you have exposure to both. I got negative 7 halves, oops, and I got to divide that by 2. This, and then divide by 2 again, which is, and square that. I'm going to go negative 7 halves times 1 half squared, which is negative 7 over 4 squared, which is 49 over 16. So that's what I'm adding. 49 over 16 here, and 49 over 16 here. I got 2. I've got x minus, this is what's always going to be what goes there, equals, that's 49 over 8. 2 times 49 sixteenths is 49 over 8. This is 49 49ths, which is not what I want. I don't want a common numerator, I want a common denominator. So it's 8 eighths. So that is 57 eighths there. I'm going to multiply that by half to get rid of that 2. Multiply by half here. So I've got x minus 7/4 squared equals 57 sixteenths, at which time I will take the square root. I have a positive and a negative, and x minus 7/4 is here, equals, plus or minus, I'm going to split that up, square root of 57 over square root of 16 is 4. And add 7/4 to both sides, and I have x equals 7/4 plus or minus square root of 57/4. So 7 plus or minus the square root of 57 over 4, if you want to write it as one single expression, either way is fine. Or you can write them 7 plus square root of 57 over 4, 7 minus the square root of 57 over 4. I do want to kind of show you what I was talking about here at this point. 2x squared minus 7x equals 1. If you wanted to just divide through by 2 right here and have x squared minus 7 halves x equals 1 half, and then it's still negative 7 halves x, a lot of this is going to be, then add 49 sixteenths and add 49 sixteenths. I don't have to do it times 2 because I've divided through by 2 already. And then we know this is x minus 7/4 squared. Just going off the work we had before, equals 57 sixteenths. That just seems like I got there a lot easier with this by dividing by 2 first. So that's an option. That's an option. All right. Well, good luck to all of you.